Okay, the day 4 lecture is on the graphs of sines and cosines. So we're going to be graphing these using only period and amplitude changers, we call them. Okay, to graph the trig functions, use a traditional window. Actually, I'm just going to draw this because, again, I'm not able to share. But you could just use your calculator, I guess, or Desmos or something like that. But we're going to graph sine and cosine on this picture right here. So the sine curve starts at 0, goes up to 1 at pi over 2, goes down to pi, goes down to here, and goes over to there. You can remember this from the unit circle, by the way, right? Because at 0, we're at 1 comma 0, so the sine value is 0. Up at the top, you're at 0, 1, so that's why at pi over 2, you end up getting 1. Back over here at pi, you end up getting negative 1 comma 0, that's why you're back to 0. At the bottom, 3 pi over 2, you're at 0 comma negative 1. That's the negative 1 at the bottom. And then this, of course, is 2 pi. So this completes the picture of the sine. For the cosine is the x-coordinate. So it starts at 1, goes to 0, then goes down to negative 1, up to 0, and then up to 1. So it would look something like this. Okay, I'm only drawing one period of them here, but it turns out that since we can keep rotating around the circle as many times as we want, the picture technically continues infinitely far in both directions, right? It would just complete doing this. So, for example, in the pre-calc, the point is these are great models of hours of daylight or temperature during the day, right? Anything that's periodic and goes up and down. Okay, let's remind ourselves of these properties of these two functions. So the domain of sine and cosine were both negative infinity to infinity. The ranges were both 1 to 1. We saw that in the picture, by the way, because we could see that the picture of those two trig functions only goes up to 1 and down to negative 1. Sine does have symmetry. It has an odd symmetry, right, rotational about the origin, and cosine has an even symmetry, reflectional over the y-axis. Both of these functions have a period of 2 pi, one rotation of the circle. The sine function has a y-intercept located at 0, 0, but the cosine intersects the y-axis at 0, 1. The x-intercepts, when your output is 0 for the sine, when do I get zeros out? That's at here and here, so those are integer multiples of pi. And then for the cosine, it equals 0 at the top and the bottom, so those are odd multiples of pi over 2. You should have been hearing that. This is like the third time we've been talking about these in different contexts. In one rotation, the maximum value of 1 for the sine occurs at the top of the circle, so I'll label that here as a pi over 2, and the min, the negative one, the lowest you get, is at 3 pi over 2. Whereas for the cosine starts at its maximum right-hand point, so that's 0, and its minimum left-hand point, the furthest it gets to negative 1 over on the far left-hand side, is of course pi. That's a summary of kind of the important pieces of information. Remember, minimum occurring at pi comma negative 1. If we scroll up here, you can see it happening at the pi comma negative 1 on the cosine curve. Maybe I'll label this too. This is a cosine, and this one is the sine. Okay, let's use that information now. So let's graph the function 3 sine of x minus 1. From functional transformations, we know the minus 1 simply means we're going to be shifting down 1 unit. So this is going to become a sort of new x-axis for this picture. And the 3 was a vertical stretch factor. So instead of going up and down between negative 1 and 1, this is going to now go up and down 3 units. So it go 0, 1, 2, negative 2, negative 3, negative 4. One period goes from 0 to 2 pi. Halfway between 0 and 2 pi is pi. Halfway between that is pi over 2. And then count with me. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. And the sine function parent starts in the middle, goes to the top, back to the middle, down to the bottom, back to the middle. So there is a beautiful sine curve. Of course, the 3 was a vertical stretch. -1 was a vertical shift. Those are just analysis, right, from our A2As. Now let's draw cosine -2x, right? Actually, I'm not drawing the parent function. I'm doing that off to the side. I think that's okay. So cosine -2x, what's the cosine -2x going to do? Well, the negative is a flip over x-axis. And remember, the 2 is a horizontal compression. So instead of having a period that goes from 0 to 2 pi, like a normal, I'm just going to draw this from 0 to pi and tell you that it repeats. So I'm going to go from 0 here, and I'm going to go out to pi. From 0 to pi, what's half of that? That's going to be a pi over 2. Half of that is a pi over 4. And then count with me. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Your amplitude, the high and low that you got to, was 1 and -1. That didn't change. Highest was 1, lowest was -1. And the cosine parent graph starts at the top, so this one's going to start at the bottom, middle, top, middle, bottom. And that's going to give us a beautifully formed cosine curve. Strictly speaking, if I were doing what it asked for, I would repeat this and do it one more time over here, but I don't want to get that detailed into it right now. Okay, don't forget the summary of all the analysis transformations here. Multiplying is a vertical stretch if you're bigger than 1, and it compresses if you're less than 1. Inside with the argument, usually reversed, right? Opposite of what you want. So multiplying by a number bigger than 1 is a compression, stretch if you're less than 1. Adding a number to the end is a shift. It's either adding a positive number is going to move you up. Adding a negative number, subtracting in other words, moves you down. Inside the argument, reverses roles again. So positive is left, negative is right. And finally, a negative on the outside is a reflection over the x-axis. And if you put a negative on the inside, this causes reflection over y. Okay, so let's try this one now. This one has a negative inside of it, so I'm going to use the eoid right off the bat because I don't want to deal with the negative. I can instead not ever have to deal with a negative sign in here because sine is odd, cosine is even. So I'm just going to pull that negative out. And when I draw a graph of this object, then I see a vertical shift of up 1. So there's my up 1. I see a vertical stretch factor of 3. So I'm going to go from 1, I'm going to go 1, 2, 3, 4, 0, -1, -2. I'm just drawing these in as guidelines to sort of help me. The period is usually 2 pi, but now I have a stretching factor of 1/2. So I'm going to take this divided by 1/2, yielding 4 pi, which means that my period is now going to go from 0 all the way out to 4 pi. Halfway between 0 and 4 pi is 2 pi. Halfway between that is pi. And then you count with me to get a 3 pi. And finally, I'm just going to graph it. So remember, the sine function parent looks like this. So I'm going to start in the middle. And then I'm going to go to the bottom, because it's a negative sign. Middle, top, middle. And that's a beautifully formed sine curve without the aid of a calculator, right? Just knowing a few of the properties and some of the basic unit circle values. Okay, I've been using this word accidentally all the way through, but you'll see the habits I get into. So we call the number out in front, the absolute value of that number is called the amplitude, and that's your high-low number. And then to find the period, since it's a compression value when it's on the inside, we just take the regular old period, which is 2 pi, and then divide by b. So the period is how long a picture takes to do its thing, right? It's going to complete one rotation of the circle, which means one cycle of the trig graph. And the amplitude is how high and low you get. So amplitude was the absolute value of the vertical stretch factor. So here it's a 3. Absolute value of negative 1 is 1. Absolute value of 3 is 3. And the period is found by taking the compression factor. So it's the old period of 2 pi divided by the 2, which is pi. In the second one, it's 2 pi divided by this number, which is a pi. So that's going to yield a 2. And again, we don't care about negatives because the even-odd properties bring the negatives out in front. So this will just be a 2 pi over a half, which is the example we drew before. That's going to be a 4 pi. Okay, last set of problems. Let's see if we can actually find some equations for these. So for this function, looking at it from this perspective, we can see that the parent function is a sine graph. I can see that the amplitude is 4. It goes up and down 4. And I can see that the period goes from 0, 2 pi, 4 pi, 6 pi, 8 pi. So I'll take 2 pi divided by 8 pi to see what my compression factor is. Compression factor is 1/4. And there are no shifts. So that's finally the answer to this, is just 4 sine a quarter of an x. Let's try it on B here. This time the parent function, thinking of it like this is a sine curve again. Although this time the sine starts going down instead of going up, so I'm going to put a negative out there. I can see the amplitude is going up and down 2. And how long did it take to do its thing? It took 4 to do its thing. So I'm going to take 2 pi, divide by 4, yielding pi over 2, and that's going to go in here. Again, no crazy shifts, so I didn't even have to work. You could actually view it as a, if you want to make it harder on yourself, you could make it a cosine graph with a shift by starting here. But let's make it easy. C, I'll view it as starting here, so I can see a nice cosine graph, although flipped upside down. Amplitude goes up and down 5/2. And it took 2 to do its thing. And 2 pi divided by 2 is pi. So that's the graph. Let me just write f of x in front of it, so we're using all our functional notation. Circle or box and a smiley face. And then our last problem finally does have a shift here. So with the shift, the one extra thing to worry about is we have to look in the midline. So I can see that this graph, since that's negative 1/2 and that's negative 3/2, I can see that there's been a down shift by 1, right? Because negative 1 is between those two numbers. I guess I'll view it as a sine curve, but upside down because it went down first. And this one's a little tricky, a little sneaky, is that since from the middle you go up 1/2 and down 1/2, right? From the middle line of negative 1, you go up 1/2, down 1/2. Your amplitude is 1/2. You don't get to just read off the number. It's a coincidence. It's negative 1/2 is the number here, but it's really the up-down from the middle. And then it looks like, what's our period going to be? It's going to be 2 pi divided by, this took 4 pi over 3 to complete its cycle. So 2 pi times 3 over 4 pi. It looks like a 3/2 x. So our final answer here is f of x equals negative 1/2 sine 3/2 x minus 1. And this completes all 4 days.